Hi everyone, I'm Madam Roslina from Politeknik Seberang Perai. In the world of electricity, there is a fundamental law that lights up our understanding. Welcome to the Ohms Odyssey. In this video, we will learn the concept of Ohm's law and how to apply Ohm's law to resistive circuit with AC source. What is Ohm's law? Ohm's law is a fundamental principle in electrical engineering, named after the German physicist Georg Simon Ohm. It states that the voltage across a conductor is directly proportional to the current flowing through it, provided all physical conditions and temperatures remain constant. In mathematical terms, it expressed as I equal to V over R, means that the current I flowing through the conductor is equal to the voltage V across it divided by the resistance R. You can use this golden triangle to solve for any of the three variables given the other two. Need to find current? Cover I on the triangle and you get V over R. Want to calculate voltage? Cover V and you have I times R. Ohm's law in AC circuit becomes I equal to V over Z, where V becomes V maximum, I becomes I maximum, and R becomes Z, where it represents impedance, a concept that combines both resistance and reactance, accounting for the opposition in the circuit. From the circuit, VR equal to V max sin omega t. Let's break it down. VR is the instantaneous voltage at any given moment. Vmax is the maximum voltage, and omega t represents the angular frequency, how fast the waveform oscillates over time. To find the instantaneous current, IR, we take the instantaneous voltage, VR, and divide it by the resistance R. It's like determining how much current flows through the circuit at any given moment. In our circuit, we have an AC voltage supply and a resistor. The voltage across the resistor, denoted as VR, is given by the equation VR equals Vmax times sine of omega t. Vmax is the maximum voltage and omega t accounts for the angular frequency and time. As we know, Ohm's law states that the current flowing through a conductor is directly proportional to the voltage across it. In an AC circuit, the current flowing through our resistor, denoted as IR, is equal to VR divided by R resistance, which is equal to I max times sine omega t. Let's look at an example. Imagine you have an AC circuit with a voltage waveform given by VR equal 10 sine 100 pi t volts, and the resistance is the circuit is R equal to 1000 ohms. Calculate the current I in the circuit at t equal to pi over 200 seconds. From the question, our given values are VR equal to 10 sine 100 pi t, R equal to 1000 ohms, and t equal to pi over 200 seconds. Ohm's law in AC circuit is IR equal to VR over R. Let's substitute our given values into this question. We will get IR equal to 10 milliampere. Next, we will learn how to measure current in an AC circuit based on the example given. Here are the tools you will need for this experiment. Power supply set to 10 volts, a circuit with a 1000 ohm resistor, an ammeter to measure current, a multimeter to measure voltage. Begin by setting up your circuit. Connect the power supply to the circuit and make sure the resistor is in place. The resistor in this circuit is 1000 ohm. Set your power supply to 10 volts. This is the voltage we'll be working with in this demonstration. Next, connect your ammeter in series with the circuit. The ammeter measures the current flowing through the circuit. And don't forget the multimeter. Connect it in parallel to measure the voltage across the resistor. Now, it's time to power up the circuit. Turn on the power supply. Use the multimeter to measure the voltage across the resistor. Make sure you are getting a reading of 10 volts. Now, let's check the current. The ammeter should give you a reading of the current flowing through the circuit, which is 10 milliampere. And there you have it. You have successfully measured current in an AC circuit using a power supply, a resistor, an ammeter, and a multimeter. Remember to always double check your connections and stay safe when working with electronics. I hope all of you have a better understanding about Ohm's law. Thank you.